I'm Sandra Gesing. I'm the director of the Center of Excellence for Science Gateways, SGX3. You are at the monthly webinar, and it's our special, you know, that with the faculty hack. And with having said this, I'll give it directly to Linda because she's organizing this.
Okay. Hello, everyone. I'm delighted to welcome you to our SGX3 webinar devoted to the Faculty Hackathon events. Faculty-focused hackathons are for high-performance computing curriculum design. We've operated this hackathon now for, we've had 3 iterations of our hackathon. This year will be our 4th. We're looking forward to it, and we'll hear more about that at the end of the webinar today. But we've had great success and getting really good feedback from our faculty who have been involved, faculty who have who want to upgrade their existing courses, enhance their existing courses with HPC content and with Science Gateway content. And we provide them with a mentor. And over a 2-week or so period of time, we work with them to modify that course outline so that when they leave, they're ready to go with a schedule, implementation schedule at hand, and just all the assignments they need, all the also the challenges and examples that they need in order to make that class revision successful. So our workforce development team is very proud of this hackathon effort. We have a dynamic team of partners that work with us, including Omnibond, who's been with us from the beginning, and Oak Ridge National Laboratory partners who have just been exceptional in terms of providing support and mentors for our effort. John Holmen is part of that Oak Ridge National Laboratory team. John earned his BS degree in computer engineering and electrical engineering from Kettering University, and he also got his MSc in computer engineering from Kettering University. His PhD is in scientific computing, and he got that from the University of Utah. His research interests center around deep-rooted passion for understanding how to make effective use of arbitrary hardware and software stacks in computing systems, and sharing practices and experiences with the related community. He is at Oak Ridge National Laboratory an HPC engineer. And so he works there to ensure the functionality, the performance, and usability of pre-production of HPC systems through activities that include test development, system testing, software installation, documentation, and early user support. As I said before, our team is just delighted to have him work with us. He has taken the lead in several publications that revolve around our faculty curriculum enhancement effort. Thank you, John, for that. Including the presentation at the International Conference on Games and Jams that took place in Copenhagen in the fall of 2024. And there he led us to receive the Best Event Award for the whole conference. And that's an international conference. So it's real exciting. And he's made a very valuable contribution to our effort. I'm going to turn this over now to John, and he'll tell you more about our HPC faculty curriculum enhancement effort and the work that goes behind the scenes in making that successful. Welcome, John.
Thank you very much for the kind of introduction there and opportunity to present. I queue up the slides here. you have my slides and full presenter there? Excellent.
Yeah, no.
Thanks again there for the introduction. So today I'll be speaking a little bit about our Faculty Hack events, in particular highlighting some of the work with the co-authors here that we recently presented as part of this event report. So at a high level, we're going to be talking about faculty-focused hackathons for high-performance computing curriculum design. To kind of set the stage a little bit, wanted to speak a little bit to high-performance computing. High level, it's essential as experimentation and theory for helping go through advanced science and lets us solve problems that may be otherwise too dangerous, too expensive, too complex, for example, to do, say, experimentally. So pictured on the right side here is Frontier, which is an X-scale supercomputer hosted at the Oak Ridge Leadership Computing Facility that goes through and enables some of this breakthrough science. One of the caveats with supercomputers in general, however, is that students in the next generation of workforce need a typically very specialized set of skills to make effective use of these systems, which can be problematic if, for example, their curriculum doesn't have much content for that. So to kind of give an example of some of what HPC enables here is pictured here on the right are some Mars lander simulations recently conducted on Frontier. NASA has been exploring ways to go through and safely land a vehicle carrying people in it on Mars. So this kind of falls in that too dangerous category of it's not really practical to continue to send these manned vehicles up into space, not knowing how they'll perform when landing. So our system Frontier enabled some first-of-kind test flights as a part of these simulations that let us simulate new levels of resolution, incorporate physics they previously couldn't, and simulate longer durations of time that past systems were unable to do so. So kind of returning to the academic realm, there's limited support for educators looking to bring advanced data and computing resources into their curriculum, for example, HPC resources. Some of these challenges center around things like existing programs maybe not being easily accessible. For example, with the Department of Energy's Visiting Faculty Program, participants need a research track participation before being eligible before the teaching track. Additionally, faculty may have little time to create these new materials, especially if they don't have, say, an established research program supporting that. The existing resources may be overwhelming too for faculty new to HPC that maybe don't know where to begin when looking at a collection like HPC carpentry or some of the CS and parallel content, or in general may just be looking for mentorship to help ease this process. And then additionally, some of the faculty tend to work on their courses independent of one another. So a model that SGX3 has been exploring are hackathons to help address some of these challenges. Hackathons we may commonly know in a more student-focused context where, say, students compete in time-bound events towards, say, prizes. At a high-level hackathon is a time-bounded event with participants forming teams to collaborate on projects of interest. So this model can help solve some of these challenges as they're openly available to everyone. They serve to dedicate time for specific work to be completed, for example, curriculum development. They provide access to mentorship through the mentors, both technical and peer, that are brought in through, for example, our Faculty Hack events. And they go through and foster knowledge transfer both within and across communities, given this multi-team aspect, bringing a lot of folks together from potentially very different backgrounds and disciplines. So with hackathon model in mind, SGX3 has been experimenting with that to provide support for faculty wanting to bring advanced computing resources and data resources to their curriculum. So Faculty Hack, as you may suspect, is a combination of the words Faculty Hack, faculty, and hackathon. It was launched in 2022 by the Science Gateways Community Institute in collaboration with Texas Advanced Computing Center, Omnibond, Oak Ridge National Laboratory, Carnegie Mellon University, and the University of Tartu, with some of the 2024 sponsors or supporters here featured on the right. Include some of the same collaborators as well as USRC, HackHPC, and STAR partnerships. As mentioned, we have had 3 successful events to date in 2022, 2023, 2024. I'll give a little bit of an overview on the outcomes of those towards the end of this talk, as well as invite you to our forthcoming up, which I'll have more details later on as well. So we're going to shift gears a little bit and talk about what the FacultyHack model is. It's based on a model called HackHPC and builds upon, leverages tools from the Hackathon Planning Kit. If you're curious on what each of these looks like, there's resources at the bottom that will provide more details. At a high level, the kind of table here on the right captures the key differences between the FacultyHack model and the HackHPC model. I'll touch on a little bit on these in the slides to follow, but some of the most notable changes are the team formation, the actual hack activities itself, how check-ins are handled, and then the final presentation. So at a high level, the FacultyHack event brings together faculty participants in STEM to go through and essentially bring one of their courses that they want to revise to incorporate, say, HPC resources or more broadly, advanced computing and data resources. So through the event, they're paired with technical and peer mentors and work towards this common goal of revising their courses, with some of the hack sessions, for example, consisting of things like brainstorming ideas for how to incorporate, say, a certain HPC system into the curriculum. So participants or hackers in FacultyHack events or teams consist of hackers and 1 to 2 mentors. So it differs from a HackHPC event where HackHPC is typically 2 to 3 students. Here is typically 1 to 2 faculty for FacultyHack events who come from 2 to 4 year degree granting technical trade schools, colleges, and our universities. Through the years, there has been a concerted effort to go through and invite faculty from minority serving institutions. To that extent, about 76% of past participants have come from that demographic. So shifting gears a little bit, FacultyHack and HackHPC events in general offer incentives for those that participate to not only attend the sessions, but also produce deliverables and output in the terms of, say, code for student-focused competitions, or here, revised course descriptions and action plans for FacultyHack. So unlike HackHPC events and kind of the more general hackathon model that use prizes as incentives, FacultyHack uses travel support and honorariums. In particular, faculty participants that go through and participate in the program, they're given travel support to attend the annual Gateways Conference. And as a part of this, they're also given an honorarium if they go through and complete certain specific challenges for the event. Some of these challenges include things like attending the virtual sessions, the conference, as well as presenting a poster and writing a blog. And all of the support is defined by the SGX3 Workforce Development Supporting Grant stipulations. So for HackHPC, there's 4 key roles that are used for events. And FacultyHack events use 3 of these roles. So those are organizers and staff, mentors, and sponsors. The 4th role that's not used are judges, as there's no competition in the case of our FacultyHack events. So organizers and staffs here are the professionals from academia, industry, and other research organizations such as national laboratories that handle all the planning and work behind the scenes, for example, recruiting mentors, recruiting participants, hosting some of the training, coordinating the funding. The mentors are broken down into 2 categories. We have both technical and peer mentors. Technical mentors, such as myself, are individuals that come to the events with relevant technical expertise, for example, in high performance computing, Whereas past mentors or peer mentors are past participants that have participated in earlier iterations of the event and help bring valuable knowledge on not only what the participants of the current year can expect, but also much more from that academic realm that some of the technical mentors maybe aren't as closely involved in. Then sponsors often come from HPC technology providers and provide support in the form of, for example, HPC resources or data storage solutions. So here is an overview of the Hack HPC procedure, which faculty events follow quite similarly. It's broken down into 8 activities. There's a planning phase to coordinate all of the logistics in terms of how and when you'll host the events, coordinating some of the funding, things along those lines. Then there's a recruiting phase for identifying not only mentors, but also participants for the program. Then there's breaking out a web page that's essentially going to host all of the event information, some of the artifacts created by teams as a part of their deliverables, and then inviting the recruits, both mentors and participants, to a Discord server where they're going to communicate with each other throughout and within the event, with the kind of last 4 being framed around the actual hackathon itself. So they typically kickstart FacultyHack events with online training sessions where participants will get training on things such as how to use, for example, a training cluster at Oak Ridge that we've used in the past support events, or for example, how to use a data storage solution. And then there's a kickoff meeting where your participants will meet their mentors. And there's some team formation, identity formation, kind of let teams create a fun name and an identity for themselves. And then we get into the actual hacking sessions. And this is a series of check-in sessions that we host where there will be outbriefs on activity between the sessions with time to work with your mentors afterwards for the actual hacking itself, with the event as a whole culminating with a final presentation session. So some of the key changes we have relate to team formation. In a Hack HPC event, participants, which are students, they'll go through and kind of pick and choose which project they want to work on, and that'll determine who their mentors are. Whereas in FacultyHack, there's some matchmaking behind the scenes by the organizers and staff involved to go through and help match the courses that faculty participants are bringing to the expertise of the mentors in the mix. So handled by organizers in the case of FacultyHack. The other key difference are the hack day activities. In a more traditional hackathon, you may be competing in a code competition to deliver some sort of code project, whereas here you're working with your mentors to brainstorm ideas on ways you can improve your course, sharing resources for, say, HPC-related materials that you could bring into your curriculum, as well as working on deliverables. With the kind of 2 final key differences being with check-in sessions, which are once daily here with the FacultyHack model, as well as the final presentation. Whereas a Hack HPC event uses a virtual presentation, FacultyHack uses a conference poster presentation. So with this structure in mind, here are some of the kind of key outcomes pieced together by the organizers. At a high level, participants will work to bring HPC technologies into their courses with 5 key expected outcomes. They essentially want faculty coming to the event to generate a plan for their course revisions, including, for example, creating a revised course description itself, and then writing an implementation plan and a schedule for how they're going to actually pull off these revisions using the resources that have been collected. Another outcome is collaborating with these mentors who are going to go through, provide some of the use cases, resources, and suggestions for next steps. Identifying ways to secure resources, for example, HPC system access, to use for instruction. And then identifying ways to collaborate not only with educators at their institution to help with course revisions, but also with the broader community and HPC educators and technical personnel in general. So one of the other key differentiators with a kind of general hackathon and FacultyHack is they've taken effort to incorporate professional development to this. So this is accomplished through the Gateways Conference series, with participants being required to present posters about their revised courses at the conference itself, with pictures here on the right being some of our past participants with the poster on the top, and those participants actually being winners of the 2022 Gateways Best Poster Award. So this is done to help encourage knowledge transfer and networking opportunities for participants there, as well as provide them an opportunity to really engage with the broader community, as well as meet some of the FacultyHack organizers. So to give you an example of what one of these posters looks like, I've included one here on the right. The teams are tasked to prepare this alongside their mentors. So the poster itself is going to document things like your revised course description, some of your resource needs, example exercises, as well as mentor suggestions, for example, on ways to move forward and continue to incorporate HPC into your curriculum. To help with this, the organizers do provide templates and example of past posters, so you're not doing this from scratch here. And to kind of shift gears a little bit, I wanted to go through and touch on some of the past events. So 2022 was our inaugural event. It was held over 6 weeks, and each week there was a check-in. For this event, we had 9 faculty members from 6 different institutions represented. And of those members, we formed 5 teams, each that had 1 to 2 faculty participants and a technical mentor. Note here, we didn't have a peer mentor, as it was the first iteration of the FacultyHack. So there were no peer mentors in that scenario. So to kind of give you a feel for some of the courses that were brought, we had an accounting for non-accounting majors, computer programming, data mining and machine learning, principles of distributed systems. And if you're curious to see some of the artifacts from this or the other events to follow, I've included the event pages from each at the bottom of these slides. So you could go through and see some of the, not only the teams, but some of their deliverables, including past posters and, for example, outro slides. So for 2023, the event was actually condensed down to 1 week, where we had consecutive daily timeline check-ins for faculty to go through, present on their deliverables and progress. In 2023, we had 7 faculty from 6 different institutions and formed 6 teams with these faculty. Again, 1 to 2 faculty participants here, 1 technical mentor, and then a peer mentor, as we had faculty from past events in the mix as well. Some of the courses brought this year were computational mathematical biology, computer networks, cybersecurity, introduction to data science, introduction to electrical and computer engineering, and parallel programming algorithms. And our last event in 2024 was again a 1-week event. However, it had an optional week 2 that was used for example, refining participant posters and going through getting additional feedback on some of their plans for implementing and revising their courses. Similar structure as it had daily check-ins. And this also incorporated mentor training in 2024. In that year, we had 9 faculty members participate from 7 different institutions. And this time around, each faculty formed their own team and were paired with a technical mentor and peer mentor. So some of the courses brought in 2024 included bioinformatics, computer forensics, data science, introduction to computational fluid dynamics, operating systems with Linux, parallel and distributed computing, and a course on terrorism, disasters, and epidemics. So as you can see, across the years, we have quite a wide variety of courses in the mix. And it's been really interesting and exciting to see just the variety and the different ways that folks have found to incorporate advanced computing and data resources into these courses. So shifting gears a little bit, one of the kind of key focus of this event report that was mentioned were essentially looking into ideas for ways we can improve this model. So some of the ideas that have been bounced were creating a central resource repository, for example, to store resources that are collected across teams across the years, incorporating not only curriculum material, but also professional development resources for the faculty that come to participate in these events, to go through and help them advance in their careers, for example. Going through sharing existing course materials with mentors before events to help them get more acclimated with it before actually participating in the hack sessions. We've also had pitched the idea of a panel, for example, during faculty hack events for past participants to share their experience, as well as guest lectures during the revised courses for mentors to see kind of what came of their faculty participation in the events. And then one of the others were kind of another way to incorporate mentors into the actual course with post-course updates to provide feedback for essentially what worked, what didn't in terms of the revisions. And if you have any ideas on ways to improve on this model, I'd love to hear from you. So definitely don't hesitate to reach out there. And just kind of wrapping up on this portion, we've applied this model successfully for 3 events now that have all culminated in in-person events at the annual Science Gateways Conference and made iterative refinements across the events. And as mentioned, the 2025 iteration of this event, applications are now open, not only for faculty participants, but also for mentors. And this year, there's support for 10 faculty participants. And as a part of this, and faculty hack effort, we wanted to spend talk of past participant interviews to go through and help us better understand how resources were integrated, the role of the event in advancing curriculum. And then we hope to go through and use some of those findings to essentially make the event better for future iterations there. And if you want to dive a little deeper into any of the model itself, I encourage you to go through and check out this event report that we recently pieced together for the International Conference on Game Jam, Hackathons, and Game Creation events. Essentially does a deeper dive on a lot of the content presented here. And then with that, I just wanted to give a few plugs. So with Faculty Hack 2025 coming up, it's a 2-week event this year with dates tentatively scheduled there for September 8th to the 19th, where participants will go through, have a chance to receive not only travel support, but a $500 honorarium if they complete 4 challenges, which this year are attending all of the training sessions, attending the conference, presenting a poster at that conference, and then writing a blog post about your experience. More details and that application form can be found at the link below. Next, I wanted to highlight a few opportunities we had for faculty at Oak Ridge Leadership Computing Facility. So the first is our Pathways to Supercomputing Partners program. Typically, when you work on supercomputers, time will be awarded through some sort of allocation programs. However, if you're not quite ready for some of the larger programs, we've introduced this Pathways program as an on-ramp for new users to help them go through and essentially get ready for writing a competitive allocation proposal for some of these larger programs that we offer. So for those selected as Pathways partners, they'll receive access to our systems with a startup allocation to help them go through and get up and running, performing simulations, as well as giving them staff mentorship to develop a competitive proposal there with kind of 2 different routes. There's an educational route where we have a system available for those that want to use HPC resources for students, for their students to use, as well as for faculty pursuing research. We have systems available for that route as well, with more details and interest form available at the link below. then lastly, I wanted to go through and share a little bit about our high performance computing crash course. So in past years with FacultyHack, we've had participants use this as a way to supplement their courses to bring in some of the more entry-level and HPC basics through this virtual event that we host typically 1 to 2 times a year. This year's is coming up at the end of June, early July. And it's a mixture of lectures and self-guided challenges that folks will get access to our systems to pursue and do. So it covers everything from basic Unix, command line, operating through the command line, programming environments, programming models, with, for example, some of the challenges you could do being running your own simulation of 2 galaxies colliding. And encourage you, if interested there, to check out the link below. And lastly, we have our user meeting coming up as well. So if interested in learning more about Oak Ridge Leadership Computing Facility updates, as well as seeing some of our user experiences, encourage you to register there. With that, I'd like to open the floor for questions and thank everyone for the time.
Thank you, John. It's an important part of this presentation has been the suggestions for improvement that we always want to continue to improve our model to better engage our faculty and prepare our faculty for these course revisions. We do want you to understand the importance that you can play in helping us, sharing this information with your colleagues and your friends. If you're faculty, if you are students, then talk to your faculty, your teachers about it. So you can also play an important part in this effort. Are there any questions that from the audience that we want to know? Janae, I don't know if you control that or see any hands up or anything.
I don't see any at the moment.
Any
Is it
comments?
possible to get more information how we can register in that hackathon in detail, please?
So, John, you're showing your screen. Could you go to the sciencegateway.org site?
We cannot see screen, share screen.
Give me 1 second here, just pulling it up. There we go. Do you have that?
Yes.
So down at the
Not
bottom.
yet. Yeah, it came yet.
Okay, good. So that's the sciencegateway.org site. I wanted you to show the whole process of getting there. Start back at sciencegateway.org.
Could you please share the link on chat?
Yes, I can put it in the chat.
Thank you.
Yeah, I just dropped it in chat there. And the application is here at the bottom, which will take you to a Google form that lets you go through, pick and choose whether you're a participant or a mentor. And then it'll take you through the motions for there. And the selections will begin June 20th and continue until all the slots are filled there.
But you should have a course outline or syllabus from a course that you've taught previously. That's going to be critical that you can share with us. And we do hope that you can, it takes place in September. So we expect you to offer that course in the spring. of the following year. So the 2025 participants will be asked that it be a course they're going to offer in the spring of 2026. We have it sometimes we have selected participants who wanted to revise a fall offering of a course, and we have accommodated that. But we ask to report at the end of the spring, and so for that reason, we encourage you to select a course that's being offered during the spring semester.
Any other questions?
Do we have anyone who is interested in mentoring? Because that's another area where we can use assistance, both mentoring for the faculty hack, and we also have a student hackathon as well. So we encourage you to contact us. John has his email address there. Just send him an email and say, I want to get involved. I know a faculty member that I want to recommend, or I'd like to serve as a mentor, a technical mentor for this program, or I have some resources that I would like to share with the faculty members. Just please let us know, and we will definitely get back in touch with you with that. Okay, so we do have a couple of participants who have on this call who have been through the process with us. Let's see, Dr. Akbari is here as well as, yeah, there you are. You want to say a word?
Yes, hi, Dr. Ilana. Yeah, actually, I participated in the event 2022. Yeah. Yeah, actually, I was teaching data mine and machine learning. Yeah, actually, I have been working in this area for a long time, but I didn't get a chance to work with or get exposed more in deep for HPC and other resources for high performance computing. So this opportunity actually gave me this chance. I with the mentor, I figured out how to incorporate high performance computing and parallel processing with machine learning algorithms. Actually, by the end of the opportunity, I get a very good experience. I learned more about resources, available resources from science gateways, also for other resources from, for example, national labs. I made some connection with more people now in the field. So actually, it was a great opportunity for me, and I recommend it for everyone. I can get benefit from it. Yeah.
Thanks, Dr. Akbari. Dr. Caldwell was one of our original participants in the hackathon, and she's come back and helped mentor faculty members. She brought other faculty members in from her institution as well. Dr. Caldwell, did you want to say a word? Okay, Dr. Caldwell. We also have Charlie Day on the line, and Charlie is part of the organizing staff for our hackathon effort. He brings with him lots of resources from TAC and lots of experience in teaching high performance computing and science gateway concepts. And we just couldn't do it without Charlie Day. So let's give him a chance to say a word if he would like to.
Sure, you know me. If you're gonna I'm gonna talk.
Hey everyone. Yeah, actually the faculty hackathon is an incredibly awesome experience. I recommend it for everybody because, you get to teach and you get to learn and you get to apply, and it's a great bunch of people to hang out with. And I've met a lot of great connections and made some great friends, colleagues, and collaborators through the faculty hack. So hope to see you all.
Yeah, thank you. Did I miss anybody who's been with us in the past for a hackathon? Just kind of went through the participant list quickly, but we'd be glad to give you an opportunity to say a word.
Yeah, me. I participated 2024. Hello. And last year I joined the hackathon. Now it's just actually conference in Montana.
Okay.
Yeah.
And the course that you revised, and you have any results from that?
Yeah, I bought the poster over there, and my mentor was the two people from Oak Ridge, and they gave me a lot of that different viewpoints. Actually, I studied these areas that for a long time, and since I got the dissertations a long time ago about the HPC, and I wrote my own simulator on the HPC. So, and I love that conference. I got the different viewpoints at that moment. It was wonderful. Hopefully, everybody get join it.
Yeah, it's a joy having you with us too. Hopefully, your students are benefiting somewhat from this experience.
Uh,
Good.
yeah, there also my courses will be on this fall. I revised the course, the parallel computing. Yeah.
Parallel computing course. All right.
Yes.
Thank you
Yes.
for sharing that information with
Yeah.
us. All right, everyone. Well, I certainly want to thank John for taking the time to explain our model to you, and to the past participants who shared their experience with you. Again, we are looking at our upcoming hack being September, and we ask you to get your applications in early so that we can make sure that you don't, that all slots aren't full when we get your application. Because we really do look forward to sharing this experience with more faculty members. So but we need your help in getting the information out on how they can apply. So please, looking forward to seeing those applications come in. Any final thoughts from anyone? All right. Thank you, John. Did an excellent job.
Welcome.
And thank you from Janae for setting this up for us to share information on our faculty hackathon curriculum model.